I don't think I have an intro slide. My name is Ben Caro. I'm a Linux engineer. I've been doing this stuff for as long as I can remember, pretty much. My day job is a Linux engineer. Linux is also my hobby. I love coming to conferences and speaking. I live in the Pacific Northwest. I live in Portland now. And this is Debugging Workflows for Linux. So I hope this thing is listening, and thank everyone for waking up and getting here bright and early. So let me just start. So these are the topics. We're going to go, these are a couple kind of techniques that I use for system-level debugging. I'm not really covering specific applications as much, so things like, you're not going to see something like a Ruby traceback, and I'm going to show you exactly where to go poke through files to figure out where to trace it from. I will show you lots of interesting ways to do, hi guys, no worries. Lots of interesting ways to do Linux level tracing, and there's actually another talk after this, maybe it's in this room, about strace, which is one of the cool tools that I'm gonna talk to you about. No, it's upstairs. So if you like strace and you want to learn a little more, I'm sure that there's an entire specific talk about it. Yeah. So kind of a familiarity that'll help you get the most out of this talk is command line familiarity. So if you've used the command line before, you know some basic commands like ls, cat, copy, there's no paste really, that's your terminal, move, these sorts of things, you'll be good. Arguments, like passing L to ls-L to get a long output, it's gonna be a pattern you'll see. And the concept of files and directories. And I think that I don't know, maybe new computer users who have never used anything but Android or iOS don't understand the concept of files and directories because it's never really exposed to them. But if you're here and you're familiar with Linux, I'll assume you know what like a directory is or a folder is. Some basic networking stuff a little bit. So like pinging, or loading, like literally loading your web browser and trying to fetch a website. Processes, so like these are things you might be running but might not be right in front of your face, like cron. You know, it's on your system running, but it's not really, there's no cron window in front of you and you're not clicking radio buttons to make it do things.
Yeah, that's what the daemon is there for.
Exactly.
Take care of that for you.
Yep, exactly. I also talking a little bit about libraries and how libraries are used in Linux. Not like the library we have here on campus, but actually they're pretty similar. I think that's why they call them libraries. And open file handles is another thing. That's kind of an advanced thing, and I think I might be explaining that today. But it has to deal with running processes and how they access files.
You talking about pointers? Soft links, hard links, or no?
Neither. No. It's when you have a running process. In order for it to go grab a file. So like say I have my Vim process and it needs to go open this file that I want to edit. It uses this open system call and it passes the path to it, and then when it gets back is a file handle, and then it uses that to go do reads or writes or something else. And we'll start with that pretty soon because we're going to start with these awesome things, which are logs. And this isn't this sweet log ride at Knott's Berry Farm in Northern California. I think it was the first log park amusement ride ever. So logs are a really great place to start if you have something that's failing and you want to figure out why. You expect it not to fail, you expect it to work, and it's not, then the easiest place to do that is logs. And if you're lucky, there will be some logs. So let's see. So there's a couple different levels of logs that you should know about. So if you're diagnosing something like, my web server isn't starting, well, your web server, you could be considering that an application. So there's application level logs, or this might be something even like Steam. If Steam isn't starting for you and you can't play your games, that's an application level log. Below that are things like cron or your DHCP client or something else that performs a task on your behalf, but you don't interface with it directly. And those, sometimes they have their own logs, but sometimes they use another tool to get aggregated together. And below that are kernel-level logs. So like if my hard drive accidentally fell out of my laptop, the logs would go there. It's happened before, but...
How could they go into the hard drive if it fell out?
Yeah, exactly. They don't, but they do sit in memory somewhere. That's so when you have a terminal and it's got like your username at machine name, some people get really clever and put things that have to do a bunch of hard drive calls in their path. But the problem is that if you lose your hard drive, you can't press enter to get the next line in your terminal because it has to read from the hard drive, which isn't there anymore. Most people don't think that's an issue, though. That's just me with my tendency for hard drives to fall out of my laptop. So let's look at application logs first. So there's a couple different locations it could be, depending on who's running it. If it's something that's run as root, or as like a dedicated user, if you bought this giant thing from Oracle and it loves to put everything in opt Oracle, it's going to be there. Otherwise, var log is where all of the system logs go to, and the application logs that are run as root. Normal user, it might show up in this directory. So this is where Steam puts its logs. So it's just in your home directory in this secret little directory called local. By the way, if you're unfamiliar, .local, or not .local, but if you start a directory or a file with a period in front of it, it becomes invisible. So you can, if you do ls and you use the -a option, that means all, you can see all of the invisible things too. So some examples of applications are something like Apache 2 or MySQL, the server or the client, and Steam if you want to play some games. And some of these use Syslog, which I'm going to talk about in a little bit, but these are just some examples of looking at log files. So I highlighted the log content in yellow, hopefully on all these slides. This is me running a command. That's tail-1, and what tail does is it opens a file and just reads the last couple lines. Since I passed it the -1 option, it'll only read the last line. Hopefully the problem you have is at the end. Otherwise, you might need to go spelunking really deep into log files, and they can get really big. So that's what it looks like from Apache, and that's what it looks like from Steam. And so I'm going to talk a little bit about Syslog now. In some sleep-induced state, I thought that Syslog was really similar to Slapchop, because not only will it handle your logs, it will actually slice them and dice them and compress them, which is really important if you're running these big machines that are generating a lot of logs. It turns out that text logs compress really well, and if you don't do this, and it's running on this computer you never touch over here, your hard drive just fills up with logs, and then it stops working, and then you have to go remember what this computer is and where it is again. So it's pretty cool. It's a daemon that runs on your system just like cron or anything else, and its only job is to take logs in and put them somewhere or manage them somehow. And it supports like multiple levels of logs, so you can have something like an info level log or a warning or an error level log, and then you can just say, show me the error level logs. I don't care about the warnings or the debug messages or anything else. These come standard on basically any Linux distribution you're going to find, but each distribution gets to choose which they use, and they have chosen to use different ones. So I think our Syslog was the one that was used on Red Hat Enterprise Linux. I think Fedora uses another one, and Ubuntu uses another one yet. Actually, no, Fedora and Ubuntu are both systemd. So this is some of the behavior that systemd kind of slurped up. When they say systemd does everything, part of the reason is because it also handles log files. And it keeps them in this weird binary format, so you can't just go try and find them like text files. Anyway, one of the cool things you can do with these is you can say, I want to ship all of the logs on all the systems I have to this log box over there. So these support network connections and shipping logs over the network. So if you have a lot of computers sometime and you're bored and it's a rainy day, you might consider sending all your logs to one place. Talk about system logs real quick. Sorry, there's not that much logs left, and I think I have if not a demo, an example. So system logs are things your system runs, like X, which is something you stare at, but it's kind of beneath that. And DH client and cron. DH client is basically a little daemon that makes sure you have an IP address when you're connected to a network. Usually these are collected to Syslog or systemd. If they're collected to Syslog and you're lucky, you can just find it in this log file in varlog syslog. And they usually have a pretty standard format, like date, and bcaro general is the name of one of my computers that I do general stuff on. And then the process name, and then the error message, which get really long and fall off the screen. This is how you do the same thing with systemd. Instead of just looking at a text file, you can you use the journal.ctl command, and then it holds all these things in a place it calls the journal. So these are kernel logs. The next one up are kernel logs, and they're mostly dealing with hardware problems. Sometimes there's network stuff in here too. Like if you connect to a new network, you'll see you plugged an Ethernet cable in or something like that, and it puts out debug messages for that. Also, if you run a really misbehaving script, it's going to log here too. So if we look at the last 2 lines here, actually, that is a program it was a little test program that I made that intentionally did memory corruption. And the kernel caught it and told me that it found it. So these are good for kernel level stuff, so like lower system stuff, but some other things can also end up in here. So if you have a program that's crashing, it's worth running this dmessage command, and it will print out basically everything that's happened since your system booted. And sometimes these can get pretty long. So they're not written to a log file. Instead, they're held in memory. So if you reboot, you'll actually lose this data. Sometimes syslog can slip up this data too, so it'll keep a couple different reboots of system logs. At this point, I should probably explain, in Linux, there's this concept of user space and kernel space. And kernel space is the stuff that goes on underneath. It's a good way to explain that. It's the stuff that goes on that basically manages hardware. And it's a lot lower level, so you don't have as many memory guarantees as you do in user space. And user space, in comparison, are the things you'll run. It's basically the things you can do as a user versus the things your system will do. Let's see. Okay, dealing with log files, so we're back to files again. If you have a process and it's crashing, there's a couple different things you can do to try and figure out what's going on. Oftentimes, a process will support the -- verbose or -- debug options, and that might be a little too much information than you need, but it's great that that's there for us. I call it running it by hand, but so for a lot of the system daemons we were looking at earlier, like cron, you start it and it just runs in the background, and if it produces a log, who knows where it goes. So you can use -- foreground, and it'll actually just run in your terminal, and it won't return to your command line until it's done. So this can be useful for looking for the exact error that it's producing. It's also useful with strace as well. tail-f is your friend. What tail-f does is you give it a file, and it just watches that file. It outputs the last couple lines, and then it keeps it open. And if anything is ever written to that file, it'll put it in your terminal too. So you can do something like, say you're running Apache because you're running a web server. If you tail-f a log file, you can actually see the entries coming in. So you can see the visitors who are visiting your site and the logs that are being generated by that. Lastly, this is one of my favorite quotes. I don't have quotes around it, but it's you don't live in a vacuum. So if you find some error messages that are produced by these, throw them into Google, throw them into Bing, or DuckDuckGo is awesome too. And try and find other people who have had the same problem, because odds are you're not the first person to find this problem, and maybe someone has a fix for it. Yeah. So here's a little example. You just started your new job as a sysadmin for foobar.com. You've been tasked with enabling the serving of a new website that the guys in web dev have been cooking up. You have a very basic setup. It's just a Debian box. It's running Apache. You looked on Stack Overflow and you found a vhost template for Apache. It's a good site, but you have to do verification on stuff you find there before you use it. And you're just going to copy and paste that into production. So I know that you can find the problem here, but let's imagine it's 8 a.m. and you're not quite awake yet, and your boss really needs this thing in here by 8:30. So you forgot to replace me with the directory that your files are in that you're trying to serve. Otherwise, this should be good. So you type that in there. You do Apache restart to make it pick up the config file, and then that happens. It couldn't find your cat, or it couldn't find your content at all. So you're trying to figure out what happened. Why isn't this working? And you heard my talk, and you go look at log files. So you look in, you know that system logs are in varlog. So you look in there, you find varlog Apache. And then you go look in varlog Apache, and you have two logs. You have the access log and the error log. And you think, errors, that's probably what I'm seeing. So you go read this error log file to figure out what's going on. And this is kind of some simplified output, but that's what you see. And you see, oh, varlog readme, or var www readme doesn't exist. I guess I'll just go make that. Or maybe I'll fix that. So that's one of the useful things you can do with logs. But this is the end of logs. I'm done talking about logs. You don't have to worry about me talking about logs anymore. Now I'm going to talk about bad programming assumptions, or bad program assumptions, not necessarily programming. And these are the most common ones. Something like wrong permissions. So Linux has this concept of who can read and write to these files, or who can even look inside these folders. So is it running as the right user? Is it running as the user I expect? And is that user part of a group that I expect? So one of the things that's really common, especially in web serving, is they use this concept of groups to be able to group things, really. So the group that is foobar.com might have read and write access to the foobar.com directory. So this is, in the box here, is one of the cool little tricks I try when I'm trying to debug something. And if you're familiar with sudo, it's so you can run commands as root. But really, it can run commands as other users too. So I'm doing sudo su to change my user, and then I'm using www data. So on Ubuntu and, what do you call that thing? Debian boxes, this is the user that runs the web server. And normally it doesn't have a shell, so you can't really log in as it. But since you're here in your root, you can just tell it what shell you want. So you can do bin sh or bin bash, and then it'll give you a terminal. And then you can type commands like who am I, and it'll tell you who you are. And you can type in groups, and it'll tell you these three groups that you're in. And then you can go try and look at the file, or try and read the file that you're expecting to be able to access. So in this case, we have index.html, and you basically copied it there, and you use sudo. So it belongs to root. Except that you're not root, you're www data, and you're not even in the root group. So you can't read this file. So the solution to this is either to let you read the file, either by changing the ownership or by adding permission so that everyone can read it. So it's a little bonus exercise, and something that might help you keep good permission hygiene is to do this. If you're running Linux, just open a terminal right now and run this command. You don't even need to type home. Find .user root. And what this will do is it'll find all of the files that are in your home directory that are owned by the user root. And this is useful, one, because usually things in your home directory aren't supposed to be owned by root. They're supposed to be owned by you. When I ran this is the output I got. So ADB is for using to connect to Android. And when you're dealing with hardware, usually you want to be root. But it left this file in there that was owned by root, and it really shouldn't have been. So you'll probably find some interesting things about. You'll probably find some interesting artifacts from things you did a while ago by doing this. Let's see. Next up is a configuration, and I just thought this was really cool. Wow, that picture didn't turn out so well, but that's a console for a space shuttle. And it has lots of knobs and buttons, and it looks really sweet. I kind of want to be there someday. So the configuration. Is your program configured correctly? Did you just write the configuration right now? Or did you get it from a known good source? Or have you not touched it and things have worked great so far? And so that's one of the things you want to think about. But the other thing you want to be aware of is there are multiple places where you can configure a program. So, and sometimes these things are flipped around. So sometimes this is an order of precedence. So like, let's say in the global config file, you say, I want to serve my web documents out of var www. And then in a local config file, you say, no, I want to serve it out of var www HTML or some other directory. And then in an environment variable, you say, but really what I want to do is serve it out of temp. And so there are different places to configure it, and it kind of overrides at each step. But this isn't a hard order. Depending on who wrote the program, they might actually flip these two. So environment variables might take precedence over command line arguments, or vice versa. One other really cool thing is a syntax checker, and I can show it to you on this slide. If you're really, really lucky, the program that you're trying to make work has the ability to kind of check the configuration itself. So this is Apache doing it. Oh, sweet, I can highlight things. Okay. Yeah, this is Apache. And if you run it with these options, it'll actually tell you this is what I think it's configured like. And if there's an error in there, it will actually say you have this error in your configuration file at this line. You should go check that out and make sure it's okay. If you're writing Puppet, you can do the same thing. You just type Puppet parser validate, and you hand it a file, and it'll tell you if there's a problem. Usually you're not so lucky with this, because most programs don't have this, but some do, and if they do, you should use it. Next, I want to talk about libraries, and this is just a little example of something that happens. How many people have ever seen an error message like this? Awesome. Okay, good. I'm not I'm not in the weeds somewhere. So this happens mostly because the library that it tried to find there didn't exist. And there's a couple good reasons it might not exist. Like maybe you updated your system and there's a new version installed that has a different name, or maybe it got deleted when you did apt-get auto remove, because it didn't think you needed it anymore, or something like that. There's this command that you can run to figure out which libraries a program is linked against, and it's called LDD. Which Perl, if you type that in, will just tell you the location that it found the command called Perl. So in this case, I've kind of rigged this so that this file didn't exist anymore. I moved it somewhere else. So when I type LDD, it's not there anymore. It's not found, and it produces this error message when you try to run it. There's this really convenient environment variable that gets used called LD library path that you can use to specify other locations that libraries might be. So in Linux, by default, there's usually only a couple places that it's going to look for logs. So it'll look for logs in lib, user lib, and that's pretty much it. If it's on the 64 versus 32-bit system, sometimes there's lib64 and lib32, but I don't need to worry about that. So I pass it another location here with LD library path. This is how you use environment variables. And I just made a directory called morelib. And when I do that, suddenly Perl can find this libperl that it wants to load, and now I can run my little program that says print yay. And yay, Perl works. The next tool I'm going to cover is called strace, and this is a really interesting tool. It's one of my favorite tools, and I use it a lot. And basically what it does is it either runs new processes or it attaches to processes that you have running, and it traces all of the system calls and signals that makes. And system calls and signals are, I'm not going to say they're the majority of what programs do, but they're kind of the meat, and they're the most telling if you're trying to debug something, because usually when there's a problem with the program, and it's not the program's bad coding fault, it's going to be something to do with a system call. So this is the basic invocation here. You just say strace-p, and then you give it the PID of a program. So you can either type PS and then find out that Apache has process ID 100. So you can type strace-p and then 100. Or this is the subshell syntax. So what this is doing is it's just typing PID of my program and it's getting the output of that. And it's putting that here and then running this command with it. It's just a shortcut that I do to make slides a little easier to read. And what this will do is it'll take strace and it'll attach that process and just print out in your terminal all of the system calls that it makes, which is really cool. If you don't do -p, you can just try strace ls, and it'll run a new command that is ls, and then print the output for that. Word of warning: the output of strace is huge, so sometimes you have to read through it. There's a couple common options here, and I can go through some of those, but some of them aren't terribly interesting. So this is
Incantation.
yes, incantations. I'm a wizard. So these are the most common ways you're going to use this. strace-p, and if you get an output message like this, it means that they don't want you, the author of the program doesn't want you attaching to it because you might see some information you shouldn't see. But you can just type sudo and it'll fix it. Let's see, what do I have here? Yeah, this is strace-p. This is the same command that was on the previous slide. And what I'm doing here is I'm attaching to the process called libinput-gestures, which is, yes?
I'm curious, what is the mechanism by which access to process internal state is restricted in the first case?
Yeah, so when you start a new process, you can set this flag called p-attach right here, or ptrace attach. And then I'm not really sure. I mean, I know when you start a new process, you set that, and there's some ways you can even prevent root from doing it, but I'm not exactly sure how. Probably something very similar.
So there's a syscall that the process can make, or the parent process that will cause it with this flag.
Yeah, exactly.
Cool.
Yes?
Yeah, if you're interested in learning more about that, one notable program that does this is Tor, because the idea being that if a Tor node gets compromised, then you still can't use something like strace to attach to the binary to look at stuff like open relays. So you can look it up in their bug tracker if you're interested.
Okay. Yeah. In this case, the example I'm using, just to give you some really basic format and show you how it looks, is libinput-gestures, and this is the little program that runs on my laptop to handle like multi-fingered gestures on the trackpad. So if I swipe down with 3 fingers, it'll read that and then clear all my windows or something else. And if you attach to it, you can see it reading. So pointer motion is literally me moving my fingers around. Pointer axis is using more than 1 finger, and pointer button is obviously clicking. And so you can just sit there, and if you're trying to debug something, it'll just keep dumping this to the terminal, and then you do your things, and then you see if something is unexpected, like, oh, why is the button event there? I never pressed a button. I better go look into that. And this is another one of the really useful commands that I use all the time. In this case, I'm doing it with door fortress, and I want to see where it's loading the logo file that it shows when it first loads. So if I do strace-e open, that tells strace only show me the open syscalls. I don't care about anything else. And then you give it the process. In this case, it's door fortress. And this is a clever little bit of code that makes the errors print into the standard out. So each process has standard in, standard out, and standard error. And I can get into that later if you guys are curious, but all this does is it tells the errors to go to standard output. And then I grep for logo.png, so because all I'm interested in is seeing the logo file. And then it does a lot of things that grep just discards, and then among other things, it tells me this. It opens from this directory. So if I want to go upgrade the logo and change it to, I don't know, a flag or something else, then I just go change that file because I know exactly what it's doing. One more strace incantation, I promise, because there's an entire other talk about this. Strace supports this thing that's kind of like benchmarking. If you use a -c option, it will measure the amount of time it spends in each syscall and give you a nice little report at the end. So in this case, I'm just copying a zip file. It's like a 2 gig zip file, and I'm copying it just to the same hard disk is how I did this. And you can see it spends 83% of its time reading and 17% of its time writing. Not terribly interesting for a standard copy command, but if you're trying to tune a program or you're trying to see why it's slow, then you can just attach to a program and let this thing run for a while and then press Control-C to stop it, and then it'll give you this nice report. So you can say, oh, it's spending 98% of its time reading. Maybe I should buy an SSD. Okay, that's the last of strace, because now I'm going to talk about ltrace, which is exactly like systrace, like strace, except instead of tracing syscalls, it'll trace library calls. So instead of open or connect or something like that, it'll actually trace calls from other libraries. So it accepts filter expressions, kind of like I did with -e open with strace, or you can do regexes or something really cool. So in this example I'm using notify send, which is a really cool command to know about if you're running desktop Linux. If you open a terminal and type notify send, LFNW is great. It will give you, they're called toasts, but it'll give you like this little temporary window up in a corner that says that message. And they can be really useful if you have like a long-running process. You'll just say, do this long-running process, and at the end send me a little message. And I want to figure out what that's doing. So I'm typing ltrace and then using notify send, and I can watch each library call it's doing. So it has to initialize a notify object, and then it sets some stuff on it, and then it calls show, and then it exits. I had no idea how notify send worked, and now I know exactly how notify send works. Yeah. So it's really useful for tracing libraries if you suspect the problem is within a library. One of my other favorite tools, one being strace and one being LSOF. LSOF will basically tell you what file handles, so like what files are open, and network connections, including if the process is sitting there accepting network connections. So here I'm doing LSOF, and then I'm doing -p to pass it a PID of a running program. And I'm using privoxy. And if you guys don't know about privoxy, I'm really excited to tell you about it. It's a little proxy that runs, it's a little program that runs on your host that you pass all your web traffic through, and it kind of cuts out all of the crap. So like tracking cookies, for example, it'll just drop those on the floor. Let's see, Facebook iframes that use up a bunch of resources, it'll just silently drop those, things like that. So I wanted to see where it was logging. And instead of just going and looking in varlog, I did it this way. So lsof-p, and then I get the PID of it, and you can see this is the command and the PID and the user. And then this FD is the file descriptor. So CWD is what what directory it's working from. In this case, just slash. And it has a couple other things, like you can see libz is an open library. You can see it has its own file open for reading stuff from. And then you can see down here, file handle number 3 is var log provoxy. And file number 4 is actually a listening TCP connection. So if you want to find out what exactly a program is doing, a combination of strace and LSOF is going to handle everything 99% of the time. An interesting note about LSOF is you don't actually have to pass it a PID. You can just type LSOF and it will happily tell you every single open file on your system, which is really useful if you have like a USB drive mounted and you want to unmount it and it says, I can't do that, bro. Something's holding it open. And you say, oh God, well, what's opening it open? What's holding it open? I can't find the window. If you do LSOF and then grep for the path where you mounted the thing at, it'll tell you exactly what's holding it open. So my program is stuck, halp. This is, if I want to impart any words of wisdom, if I die suddenly and unexpectedly in the concept of tracing, this would be it. There's seldom a problem that can't be figured out using strace and LSOF. It's very Linux specific. These tools don't really exist for BSD or Windows or anything else, but if you're using Linux, this is your bread and butter. There's some other bread and butter, like GDB, except GDB is really complicated. It's kind of the big guns for debugging. And if you get to this step, you're probably already having a bad day. I don't have much to say. This could be its own talk entirely. Suffice to say, if you get the notes here, there's a cheat sheet where you can attach to a program and then run it and step through it step by step to try and figure out exactly what's going wrong. The problem is that you need debug packages. So when programs are compiled and installed on your system, one of the optimizations that happens is they just take away variable names and turn them into like random short strings. And they take away function names and turn those into short strings too that are of no use to a human. But sometimes you can find debug packages where they left these strings in there, and then they're much nicer to use with GDB. Next, I'm going to talk about systemtap. Has anyone ever used systemtap here? Yeah. Well, I see one hand. But this is a very seldom used debugging suite. So if the other tools didn't handle it, this can kind of do some more intricate things. It has its own programming language, which sounds really intimidating until you realize that just like Itrace, no one understands the programming language at all. And everything, the only thing people do is they go to the website and they find the example that does exactly what you want to do, and then you download it and run it. And it works really well, but sometimes you don't know what you're downloading and running because you don't know the programming language. But it can do useful things like show me all of the execs that this process will do. There's another one that seemingly looks exactly like this called LTTNG, which is the Linux Tracer Toolkit, next generation. At some point in computing history, it became really popular to put NG at the end of program names. Kind of like in, what was it, 2002, everything was reloaded after the Matrix. Yeah, this is no exception. And it was created by a bunch of kernel engineers to trace things that were really hard to trace. It's good for solving performance problems, but you need like special stuff in your kernel. There are packages that handle it, but I've never used this before, so if you have to use this, God help you. So let's say we can't find it. The program must be somewhere else. I'm not sure where to look. A couple other places of where to look are network sniffing. Maybe the problem isn't on your system, but what's coming in. So you can use something like, if you're on the command line, TCP dump will grab, it will basically set your network interface to what's called monitor mode, or it's called promiscuous mode as well. And that will basically just say, maybe it says, I'm a switch, send me all of the data. Or I'm a switch. I will accept all of the data, and then I'm going to write this out to a log file, which is exactly what it does. And then you can come back with this program called Wireshark, and then it's actually got a really cool interface, and you can literally step through network streams, one packet by packet, and from it can. So it's got like a big display of packets and network streams, and then you can click one, and down below it'll actually show you exactly what's in each packet. And it's really useful for analyzing things like if you, for some reason, constructed your own network protocol and are trying to figure out if there's a problem with transmission. But most of the time, you're going to find problems on the local system using something like syscall tracing or just looking at log files. Yeah. So that ended kind of abruptly, but that's the end. Thank you, guys. Is there any questions? Yes.
Not a question, but a suggestion for a few tail tricks. So you habitually use the dash capital F instead of F. When your logs rotate, you won't think that nothing's happening.
Oh, cool.
You should repeat that for the. Will you repeat that for the recording?
Oh, yes. A audience member commented that when you run tail-f, if you instead do tail-F, if your log files slip out from under you in case you're being compressed or rotated somewhere else, it will keep showing you the output. It'll reopen the file.
And you can also you can add the n argument to a dash F, so that if you have a huge log file and you want to see like the last 1,000 lines of it plus whatever keeps coming out, so you can do something like tail -n1000-f and then pipe it through less.
Yeah.
Or even grep, so you can have something continuously going, but you're not just starting from what just happened a second ago.
Yeah, and I used to do operation stuff all the time, and I definitely used tail in that exact scenario. So I tail something, and then -f to keep it going, and then grep something, and because I'm only interested in things that match this path. Dmessage to show you kernel logs also takes a -w, which does the same thing, except on Ubuntu, which is -f, because they patched it to be that way.
Yeah. Just one thing to add, you mentioned the dmessage, the kernel ring buffer is always in memory. I found that some of my systems, it also logs to files.
Yep.
So it'll just show up in varlog messages, varlog syslog as well. So
Yeah.
that's pretty handy when that's flipped on.
Yeah, it is really nice, especially since if your computer crashes, it's not like you were expected to be able to get that. You have to reboot it and then go find it again. Okay. If there's no further questions, then thanks for coming this morning, guys.